Alright, so today we're going to continue talking about inverses of functions, and things that you need to know are that the main thing about an inverse function is that the x and y are switched. So, for example, if I wanted the inverse of just an ordered pair, and the ordered pair was 2, 3, if this was my original point, then the inverse would be 3, 2. So I would just take the x and y coordinates and I'd switch them. If I were to graph them, I could graph this original point at 2, 3. That would be the original point. And my inverse would be at 3, 2. Should be over here. So the interesting thing about inverses compared to original functions is if you graph the line y equals x, which is the diagonal line that goes right through the origin, so this is the line y equals x, I could fold my paper over on that dotted or on that diagonal line, and this point would land on top of this point. So, for example, if I had an entire function, and here's my reference line, and if I had a parabola that opened this way, this was the original graph, and then I wanted to draw the inverse would be whatever that graph folded over the line y equals x is. So basically you'd have a parabola that looks like this. Okay, this is the inverse. So graphically, this is how you could compare the original to the inverse. They would be symmetric over the line y equals x. All right, so we're going to do number 1. It says graph the relation and connect the dots. So here's my original problem. So I'm just going to graph these points. I have 0, 2, 1, 5, 5, 6, and 8, 9. Okay. Then it says graph the inverse. So if I wanted to find the inverse, I'm going to take my x's and y's and I'm going to switch them. So instead of 0, 2, I'm going to do 2, 0. Instead of 1, 5, I'm going to do 5, 1, and so on. So there's 6, 5, and 9, 8. Okay, so now I'm going to look at what would be the inverse. So I would have 2, 0, 5, 1, 6, 5, and 9, 8. All right, and then if I were to take my reference line, remember that line that we talked about, the line y equals x? You don't have to do this part. This is just to prove that it really does work. Okay, if I were to fold my paper over, all the blue points would end up on top of all the red points. Okay, so these points are the original. This is the inverse. All right, then it says identify the domain and range of the inverse. So as a reminder, domain is all the x values. So my domain of the inverse is 2, 5, 6, and 9. And the range of the inverse is all of the y values. Okay, so my y values are 0, 1, 5, and 8. Okay, so this answers the question. Graph the relation. Oh, it said to connect the dots. Sorry. Connect the dots. And then graph the inverse. So if I look at the inverse, here's that connected. And then here, identify the domain and range of the inverse. Okay, when you're done, flip over to the back. And then now we're going to use inverse operations to write the inverse of each function, which is exactly what we did yesterday. So remember, our steps are to first switch x and y. This is my y, so we have y equals x minus 4. I'm going to switch my x and y. Then you need to solve for your new y. So get your new y by itself. We have x plus 4 equals y. And then you're just going to write it using the proper notation. Inverse of f of x equals x plus 4. Okay, so we're just going to keep going with all these problems. Problem 2, remember that's your y equals x plus 2/3. Switch x and y, but leave everything else where it is. And then we're going to subtract 2/3 to get it to the other side. So you have x minus 2/3 equals y. And then I'm just going to use the notation inverse of f of x equals x minus 2/3. The next problem is y equals x over 3 minus 6. So we're going to keep everything else where it is except for the x and y. So you're still dividing by 3 and subtracting 6. Now we need to get y by itself. So you have to undo adding and subtracting first. X plus 6 equals y over 3. Then I'm going to multiply by 3. Now make sure you multiply the whole thing by 3, which means you need to distribute. So it's 3x plus 18 equals y. And then I'm just going to substitute in my function notation. So inverse of f of x equals 3x plus 18. All right, the next one is y equals 2x plus 3 over 4. So we got x equals 2y plus 3 over 4. Because you have 2y plus 3 in the numerator, we're going to get rid of the divide by 4 first. So to undo a divide by 4, you have to multiply by 4. Now you have 4x equals 2y plus 3. Now you can subtract 3. 4x minus 3 equals 2y, and then divide by 2. Now I'm going to divide each part by 2. So we have 2x minus 3 over 2. So you have inverse of f of x equals 2x minus 3 over 2. All right, last two problems. So we have y equals 5x minus 7. We're going to switch the x and y. Undo our subtraction by adding. So x plus 7 equals 5y. Then we're going to divide by 5. So we have 1/5 x plus 7/5 equals y. So remember, x divided by 5 is 1/5 x, or x over 5. So I've got inverse of f of x equals 1/5 x plus 7 over 5. You could also have left it as x over 5 plus 7/5. That answer's fine. Technically, you could also have said x plus 7 all over 5. So all those answers are probably acceptable. This one is what you would likely see on the multiple choice if it was listed. All right, last problem. We got y equals 3x minus 2. So we're going to switch x and y. Then we're going to get y by itself. So one thing you might want to do is just distribute. We have 3y minus 6. All right, now add 6. X plus 6 equals 3y. Then divide by 3. So again, x over 3 plus 6 over 3, which is the same as 1/3 x plus 2. So that's inverse of f of x equals 1/3 of x plus 2.